Okay, welcome back again. I've just thrown the formula up here to save a little bit of time. So, what we're looking at is compound interest. This is a very high level question, okay? But we still start the same way. So we always read through the question first. We make sure that it is compound. It says compound, so it is. Then we look for the information. 5,000 invested, 8.4%, monthly rests. Take to accumulate to 8,000. Okay. What we're missing in here is our time. So just go and copy that down. He 5,000 invested, so that's what he's starting with. We have an interest rate, it's 8.4. We have monthly rests. We have a total amount he wants to get to, which is 8,000. And the thing we are missing is our time. So we start the same way. We fill in as much as we can. So we've got 8,000 equals 5,000. 1 plus 8.4 over 12 times 100 to the power of 12 times by t. What we do is we solve this as much as we can. So if you remember a little bit from before, we can do the 8,000 divided by 5,000. And we can simplify what's in the brackets here. So if we type what's in the brackets into our calculator, we end up with 1.007. And we have 1.6 equals 1.007 to the power of 12 times t. Now what we have to remember is that t we're looking for is years. This may not happen in exactly 3 years or exactly 4 years. We have to use trial and error to figure out our answer. So I must say we don't have a procedure we can use to directly get an answer here. So what we do, we put in a number and use trial and error and try and systematically get down to the correct answer. So when I look at this, I have 1.6 equals 1.007 to the power of 12 times t. I substitute a number in t and see how close I can get. I'm going to start with 5. Okay? What number do I choose? It's completely arbitrary. You can choose whatever you like. You just have to realize that you try and start with one number and you'll use the second number and then narrow down the field. So when I look at this, I'm going to use 5. So 1.6 equals 1.007 to the power of 12 times 5 is 60. And I'll see how close I get. Okay? So I've got 1.6 doesn't quite equal 1.519. Alright, so my first one, not quite there. So what I'll do, try another one. So I know that the power of 60 didn't work, so let's try something different. Rather than try 5 years, let's try 6 years. So we're going to have 1.007 to the power of 12 times 6, which is going to be 72. And I get 1.6524. Again, we can see I haven't got my answer yet, but wait a sec. I'm really getting good at this. I'm getting quite close. Because 1.5 is below 1.6, 1.65 is above it, so my answer is in between those ones. So that means I need to use somewhere between 5 and 6. So let's go halfway. So I'm going to use 5.5. Oof. See, I'm getting closer. So I'm at 1.5847. So I'm getting closer. So it's still below it, which means that I'm going to have to go between 5.5 and 6. So notice how it gives you a direction of which way to go. So I'm going to skip 5.6 and I'm going to try 5.7. And I'm 1.611. So I'm just over. Maybe I should have tried 5.6. So we'll try that now. Jeez, the writing doesn't get good down this edge of the board. Sorry about that. And I'm 1.598. To be honest, that's really, really close. If I just round it, I'd get to 1.6 pretty quickly. So when I'm looking at it, it is 5.6 years. We would prefer you to write it as years and months. So 0.6 times 12 is 7.2. So it's a little bit more than that. So you notice how we're below. So we can't say it will take 5 years and 7 months. It would be 5 years and 8 months. And that's how we can do it using Maths A principles. Now, for those of you out there who are more mathematically inclined, I just want you to take a note of one part of this. And that part I want you to take a note of is 1.6 equals 1.007 to the power of 12 times t. Because I'm going to show something that we don't learn in Maths A, but if you can do it, that's what I want. So, if you can do this particular way, you are allowed to. I'm just going to delete all this. So that was all the trial and error, a little bit irritating. So we're here. Now, something we can actually look at is a principle called logs. Okay? Now, one sec, I've just got to... Okay. So what we look at is, if we use logs, this is something that we can do. So, we can write... I'm going to still bring it up here. The log of 1.6 equals 12 times t times the log of 1.007. So what's happened is, log means that we can bring down powers effectively. So when we look at this, we've done the log of both sides, and we brought the power, which is 12 times t, down, and you multiply it through. So when we look at this, we end up with the log of 1.6 over the log of 1.007 equals 12 times t. And we type this in our calculator. So there's a log button in your calculator you can use. Use the fraction button so that it becomes like a fraction as you see on the board. Now, with the calculators we have, you've got to make sure, because I just realised I didn't, to close the brackets when you type in logs or it goes funny. And we get 67.378 equals 12 times t. So it's times by 12, t is, so to get t by itself, we divide. 67.378 divide 12. And we get 5.614 years. And that is 5 years. To convert the 614 into months, you need to times by 12 because there's 12 months in a year. So 0.614 times 12, and we get 7.368 months. Now you could keep going and make this even more and more accurate if you wanted to, because you could do the 0.368. You can keep going through that way. But this method, if you understand it, is much quicker because you just type the information in, get an answer, you don't have to worry about trial and error. So that's the end of compound interest.